For the recording, what Manuel just said is that I have like 20 years of experience in industry as well as I'm a PhD student here. And that's not to brag. This is your chance to ask somebody who has been through industry. I have been at big companies. I've been at small companies. I brought a number of these software engineering practices into play at companies like Arion Labs and ClearPath Robotics and so on. And I've seen firsthand how these practices work and how they were better at Google than the small startups that I had, but also how they vary between companies. So I have a number of set slides and so on, but it will be very interactive. To be honest with you, most of the material I go through today are things that you can find very easily online and get sort of an idea, an overview of very easily. But this is your opportunity to ask questions and try to understand how does this really work? How does this impact your work as a software engineer and how you're going to practice things going forward? So this will be very interactive. Please, at any point in time, if you have a question, either put up your hands or I will ask at specific points. Just shout things out. This is meant to be very much an interactive thing. And so let's start with just what do we mean by development practices? Somebody tell me some idea. There's no right or wrong answers here. Any ideas? Before I start picking people out? What do you think I might mean by, or what would you mean by a software development practice?
Following software engineering practices like RSD, these concepts should be simple.
Yes. Yes, not REST. What was it called again? I know what you're referring to. Allocation is initialization kind of ideas. So yes, that's one piece. Other ideas? What do we mean by software development practices?
Just like the different mentalities, I guess. You think, like, for example, like from a very point of view, to what each of us just consider like we develop.
Yeah, philosophies behind software development and so on. How about over here?
Yeah, I guess I would have said something like that, like rules that you and your team follow in common to make sure that we're all on the same path and we're all following the same rules.
Yeah, the rules around development and so on. Yeah, that's very similar to how I would define things. I define architecture and a lot of what you're going through in this course, like the design principles, as being the what. What are you building? Development practices are the how. And especially if we go back to, I think Manuel told me that he's been really emphasizing the idea that software engineering is about people. Development practices are about people and organizations. They lead to how do you actually organize to get things done? And so my next question is there some universal set? Is there a set of practices that will lead to always getting the best result? And this is meant as an open question. Give me ideas, yes, no. What do you think? I see a shaking head.
Well, that's not specific. I mean, if you're talking in a very, very broad sense, I guess some things are quite obviously good and bad, but then as soon as you start making specific notes,
Okay, so the idea of granularity and large scale, some things maybe yes, smaller scale maybe no. Other thoughts? Yes, no? No, not at all? Never? Sort of like how there's good and bad architecture practices with software. There are no universals, but there are good practices. And we're going to learn some of those today. And very similar to code. Code to me is to software engineering or to architecture what practices are to organizations. The most important piece is agreement. Agreeing on what are the rules so that everybody is working together. There are no silver bullets. There are some practices that will be, what's your name? Luke. As Luke said, there are some practices that at a broad scale will be generally applicable. There are, but they will never be absolute. And things will change over time. The code that works in one moment for some set of requirements is not going to work later. The same thing will actually happen with your development practices. You start as a startup and you have very loose development practices, and then a few years later you're a company of 1,000 to 10,000 people. You need to change your development practices. If you launch something as a fixed app and now suddenly you're pivoting into something more web-oriented, you might switch from a release-oriented model to something more DevOps. And so we'll talk about some of these good practices, but you'll see that the theme is going to come up again and again, that you need to think of your organization and what do they do. So most important, what I really want you to get out of today's talk is what questions should you be asking? So that when you show up, let's say you get an internship at whether it's Grab or it's OCBC or one of the FANG companies, whatever, you know what some of the best practices are, but you also know what questions you should ask when you get there. That is my real goal. I want to take you from the YOLO coder that shows up day one and is like, vibe coding, YOLO, I can commit this and we'll debug in prog. Don't slow me down with these tests. I just want to get my code submitted, to you show up, and you show them on day one that you are the Chad coder or Chadette coder or non-binary Chad coder, whatever, and you're asking the right questions. It's not about, you can get things done. I know you all are smart. You're going to figure out how to write code. That's not enough. You get there and you start asking questions like, hey, I have this feature. How do I get it into production safely? How do I make sure that I'm meeting all your requirements? How do I make sure that it meets your style and so on, as opposed to hitting roadblock after roadblock after roadblock? And this will amplify your success in industry 100x. This is how you become a 100x coder. It's not just like leak coding, it's knowing the right questions. So we're going to go through a lot of topics. None of them are rocket science. They're just all small building blocks. And I'm hoping that you will see how they fit together. A lot of them fit together like puzzle pieces. And that's actually the challenge, is seeing how does source control fit in with versioning and branches and dependency management and code review. All of these systems interact. And again, everything is very organization dependent, so you need to figure out what works for your organization, as well as be suggesting changes as you go forward. So with that out of the way, let's dive right in. Another quick show of hands. Please, how many of you are using source control, some form of source control, on your project right now? Is there anyone not using a form of source control for some project right now? Okay. Anybody not using Git? Okay, that's basically what I expected. Git is sort of the thing that most people use. Has anyone used anything other than Git ever for source control? One, two, I'm curious, what did you use that wasn't Git? Mercurial, okay. So Git, but done in a different language. Okay, so I'm going to skip this because we've been talking about things already and we're sort of pressed for time. Your primary output as a software engineer is code. Yes, there's a lot of things other than code and there are other deliverables, but if you're not managing your code, you can't have control over your project. So, but that's sort of the obvious part. Source control is not Git. There is a lot more to source control than just Git. The point to source control is figuring out how do you control changes. Git is a tool. It's sort of like the difference between Microsoft Word or Visual Studio Code and your project. VS Code is a tool. Does VS Code dictate that you must code in C++ with a certain style? Does it dictate how you write things? No. It's a tool. Git is a tool. You can use it well. You can use it in ways that will make your life very difficult. And so the difference between Git and SCM is how you implement it. How many people have here worked on projects, whether at NUS or somewhere else, where you actually had to get authorization to submit changes or had to go through some sort of system to get? Yeah? A few people. Yeah, okay. This is what I mean by SCM. And this is what you need to think about when you're no longer a junior developer. You'll be thinking about who has access to commit. How do you take these changes? Where do they go? That is what is SCM. And there's a lot of considerations. When you show up first day at some larger company, whether it's Grab, Apple, Google, a big bank, and so on, they'll have figured this out. And you just have to figure out what is their process, which leads to my previous slide about asking the right questions. You need to ask them, where is your SCM? How do you get your changes in? Which branch do you work on? And so on. But if you are doing a startup, these are the things that you need to be thinking about. Do you do something more centralized or more decentralized? Quick question, which one is Git? I have an answer, decentralized. Who agrees with that? Yeah, most people agree. Yeah? Does it have to be? No. You can have a centralized version of Git. You can force and say things have to be committed this particular way. Git is not both decentralized and centralized. It is a tool. It depends on how you set it up. Dependency management will be determined a lot by your SCM tool. Git has some tools for dependency management. Other tools, and yes, there are other tools, have other ways of doing it. Git has some elements of scalability, but it also has issues this way. Git can actually be problematic when you get to the scale of having tens of thousands of developers working on one code base. It can be problematic if you choose you want something more centralized, and there are reasons. Anybody have any idea why would you want a centralized system? Let's say you're an enterprise, you're a bank, for example. Are there any reasons you would want a centralized versus a decentralized setup?
Protect the source code.
Yeah, how so? Protect from what? Okay, no, you're on the right track. Any other thoughts? Who might you need to protect your source code from? Hint, there was a recent story of a NUS student, very controversial. It happened within the last 6 months. Happened at ByteDance. And I was absolutely shocked. I was floored by this because it revealed extremely lax practices. And it is exactly this case. Yeah, really good question. So what does it mean to be more centralized? It means that you have some central location that determines the state of code. It's like, this is what this code base means, versus having multiple locations. So in distributed computing, typically you talk about having multiple servers or multiple nodes. Here the idea is you have something that acts like one node. You have one single node that determines this is, you ask for project X, this node has project X, and it is project X. So that's what I mean by centralized. So centralized by itself doesn't actually protect your code, but there's a reason that you can get some advantages out of it. So let me start with a slightly different question than the protection question. Let's say Manuel and I are both working on, let's say SQL Answer. This is a really good question. And Manuel says, yeah, just check out the latest version of this code, of SQL Answer. How do I know I am on the latest version, or whichever version Manuel has said? There's an obvious answer for SQL Answer if you know the project. How do I know that I'm running the latest? GitHub. Yeah, what is GitHub? It's a centralized repo. It is the source of truth for SQL Answer. Manuel can say, give me look at the latest code for SQL Answer, and I know, I just go to GitHub, I make sure I'm synced to that, I know I'm on the correct version. Now, let's say we have some decentralized setup. So my department has a Git repo. There's another Git repo for, say, one of our dependencies from another department. There's a set of repos for like libc and other things and so on. How do I know if I'm running the correct version of these? It's a bit of a problem, right? There are multiple versions across different repos all over the place. But what's the advantage of decentralization? If GitHub goes down, what's going to happen to SQL Answer? We have a single point of failure. This is the trade-off, and this is always the trade-off with any distributed system. In some ways you want decentralization, in some ways you want centralization. And this is something you'll have to think about, as well as a certain amount of scalability. You also need to think about your team, right? Maybe Mercurial is technically far superior to Git. Actually, that's an opinion I hold. I think Mercurial is a great system. I've used it a few times. It's great. But if nobody on your team knows Mercurial, is it a good choice? Maybe, maybe not. You have to decide. You also have to think of your development tools, MS Code, Xcode, JetBeans, and so on. For a long, long time before Git gained popularity, everybody had their own. Microsoft had its own Team Foundation server, something or other. Xcode, I think, liked SVN. JetBeans had CVS built into it. Fortunately, we've moved past that. So we've talked about good practices. Probably the most important thing out of SCM for software engineering is to have a single source of truth. You want to make it such that we say the latest development version of SQL Answer, it is unambiguous to everyone on the team what that means. We say version 1.0, 1.1, or alpha lollipop, we know what that is. There's a common language. That's the most important thing out of SCM. In terms of controlling changes and security, that is also another very important piece, but there's really no single set of practices that way. You will have to think about that, actually. I probably should put security as one of the most important pieces here. For those of you who haven't heard the story out of ByteDance, there was an NUS student who went to work at ByteDance, and purportedly, I do not know the true story behind this. There's a number of different stories going around. This student intentionally submitted code that screwed up a number of machine learning models and set them back months. The shocking part to me was, how were these commits accepted? This should have been caught in good SCM practices to control who's committing your code. But I guess they allowed commits anyhow, and so these commits got in, and people are going like, these machine learning models don't work anymore. So that's a very important thing with SCM, is controlling these changes. But in terms of your practice using them as a developer, consistency and small focused changes make a huge difference. Be very clear about what is being changed and why. Make sure other people on your team do this. If you see people on your team, even on your projects here, because your projects, as part of your undergrad or even graduate studies, are meant to simulate the real world. They're meant to get you thinking of how these things work, get you practicing. And so push your teammates to have good practices. That way they learn and you learn. Make your changes small, focused, be clear about what's being changed. You probably will not use a lot of branches within your teams. I would suggest you use one or two so you will learn the habit of how to use development branches, but keep them short and use them very appropriately. And we'll talk more about dependencies in a moment. I think that's all I have for SCM. Any questions about SCM? SCM is the kind of thing where the foundations seem obvious. Like, oh yeah, we just sort of use Git. But the organizational level, when you start to get a number of developers using this all the time, it becomes a lot less obvious. You start getting into like, oh, how do we do this in a way that allows people to work, not getting people's way, while at the same time making sure we don't have chaos, which is the art of software engineering. So we'll probably come back to more SCM practices and branching and labels and so on going forward. Let's talk about coding style. This is another thing that will seem simple, but the more advanced you get, the more less inobvious it will get. Quick code example. Is there one of these that more people prefer? Give you a chance to run your eyes over this. It should be fairly obvious what it's doing. Who prefers the one on the left? Yeah. Who prefers the one on the right? Yeah. So this one's fairly obvious. And the goal of coding styles and style guidelines is not just to get everybody on the right, but to get it so that it's consistent. Another piece that we get to, there's no formatting differences between these two, but which one do you feel is more understandable? In a few seconds, hands up, have a look at the one on the right. In a quick show of hands, who understands what the one on the right is doing? Yeah? Anybody completely lost about the one on the right? Just not looked at it yet? A little bit, okay. This is very much a C construct, so if you've not done a ton of C, don't worry about it. It's not meant to be a test of your C coding abilities. Who finds the one on the left easy to read? Who finds the one on the right easier to read? Yeah. This is also coding style. This is extremely clever. I went looking for examples. I've seen many examples of very clever pieces of code that are essentially impossible to read. Most of them are regexes. Regexes are brilliant for their ability to cut through text, but impossible to parse. If you haven't touched regexes or don't know what regex means, don't worry about it. This is a good thing. It's less painful for you. But we want to push people to do things today that are more like this example on the right, mostly because it's easier to understand. We want people to focus on understandability. Maybe if everybody in your team is old school C programmers, they'll get this one on the left and they'll prefer the one on the left. The point is make it so that it's easy for other people on your team to understand. So why should you care? Beyond the examples we just went through, I have had so many problems in startup land where different people coded in different styles, and I have one file that uses tabs and another file that uses spaces. One is using 2 spaces, one is using 4 spaces, and even worse, sometimes in the same file. And then you get another developer, and what do? They reformat the file. How many people have experienced this in Git or anything else where somebody changes the formatting of a file? What happens to your Git commit, your Git diffs? Yes, the whole freaking file is a set of changes. It makes it impossible. It gives you this barrier you have to diff across. It's annoying as. You don't want that. You want consistency, and you will always have differences in style. Doesn't matter who. It's going to be Manuel and I talking about Java. Java's got a fairly well-defined style. Manuel and I do things. Actually, I think we ran into this in SQL Answer. It's just like, I do things my particular way. Manuel has his way that's just slightly different. You're working on a team. You want to make sure people are working together That is far more important than having the ultra clever answer that does things shorter. Do this in the obfuscated C code challenge or your own examples of code. When you are working on enterprise, even a startup, this is not what you want. You want consistent, clear style. And that gets us to this exact meme. It does not matter whether the brace bracket is here or how or whatever it is. I have coded in organizations that use wildly different styles. The more important part is to be consistent. And whenever you can, we've talked about all of this, use an auto formatter. It's 2025, y'all. Don't be wasting your time going through and moving brackets and spaces and things around. Use an auto formatter so that what you are thinking about is more, how does this reflect what's being done? That's what you should be discussing, is how to make your code clear as possible to the reader, so that here's the thing that you will realize after a year or two of being in industry. You want to write things clearly and document them, not for anybody else. Who's the most likely person to look at your code again in 2 to 4 weeks? Luke's smiling, so I'm going to say you probably know. Who is it? It's yourself. You're going to write something, and then you're going to go on to other projects, and you're going to come back to this code. I have done this. I have gone to Git Plane and been like, who wrote this? What the heck? What's going on with this? Oh, crap, it was me. You will hit that. And the clearer you write it, remember, it's just for yourself. And then, yes, for other people as well, that's nice. But just think of yourself for a moment. You're going to come back to something. It doesn't matter if it's 2 weeks or 2 years from now. You want to make it easy. Oh, yeah, this is why I did things this way. I did things this way because if we don't do it this way, it will crash. Leave a note to yourself that this is why. This was the condition I was avoiding. I wrote it this way because this was the purpose of the feature. Make it as obvious as you can. And whatever you do, don't do this. This is my bit of humor. I have never seen this in the wild. I have seen a lot of things. I've not seen that. All right. So I don't want to spend a lot of time on coding standards. Just know that they exist, and know that your best bet is to figure out what your team uses and be as consistent as possible, and think about your reader. Questions about style before we go any further? Yep.
So how do you have this conversation with a team about coding style? How do you go about it?
So it depends on where you are in the organization. If you are just joining, your best bet is just to ask. What are your standards? How do you do things? What should I know about? What are good examples? Asking for good examples is often a good one as well. People like to show off. So say, oh yeah, I wrote this really big, PR, pull request, change list, whatever the nomenclature is at this organization. Here's a good example. And then you can ask questions about it. People love doing that. If you've been there for a while, you probably have some idea of what are the problems you've run into and what is it that you want to avoid. So, bugs that happened because somebody used an else that didn't use a brace bracket, and so it was just like the one-line version of it. This has actually happened in SSH. And you then say, okay, never again, we're not doing that. And maybe there are things you have opinions about. Maybe it's things other people have opinions about. Things you've run into, it's like you do things one way, the other person does things a different way. You decide, okay, let's decide once and for all and put it down somewhere. And that's most of it. Yeah. The other is looking at other organizations. Chances are there's a number of style guides, and you can talk about that. So yeah, really good question. It's something you have to, as an organization, you'll come up with things. And usually at first it's like, we use Google style, and here's the auto formatter, and here's a few rough ideas. And then as you go on, you add more and more rules. Yeah. Any other questions? Cool. Feel free to ask more about style later. Style is something you can talk about for a very long period of time, and with good reason. It really does make a big difference as to how maintainable your code is. Okay. Software versioning. It's again the kind of thing that seems fairly simple until you have to actually do it. This should be fairly obvious. You deployed some code, your customer's running some code. How do you keep track of this? How do you keep track of what code did you actually send to a customer? What answers would you think of? Ideas? Sorry? Version number. How do you determine a version number? What's a version number? Okay, so you sort of have a rolling number. So version 1, version 2, version 3. Okay, and how do you keep track of what is 1? How do you go back to find? So let's say I join your company. You're now on version 10. And I want to see the code for version 2. How do I find it? GitHub. Okay, so I go to GitHub. And I go to the search box. I press 2, enter. What do I find? Sorry? Sorry, the release tag. Tab. The release tab. So this is a specific feature of GitHub. So yes, GitHub does have a release feature. Do you know what that does under the hood? No? Anybody have any idea what does GitHub do under the hood when you go into GitHub and you click the release button? Any idea what does it do? Creates a tag, yes. It is going to tag. This is a feature of Git. It's an SCM feature where you tag a particular point in your commit history. And you say, this is version 2, or whatever version it was. So the short answer is, actually, it depends entirely on your deployment method. If you are going to deploy using, say, DevOps, which to me is just continuous deployment or a web service with rolling releases. DevOps to me is just a marketing name, but whatever. Versus an app store, you're going to have a version that's captured in the App Store. If you're sending binaries to customers on a floppy disk, and I am old enough, I have sent binaries to customers on a floppy disk, that is something you have to take to manage. If you have a system where it's embedded, that's a whole other way of dealing with things. That is something you have to think of. So how you deploy makes a difference for how you call your different deployments. So that's something to think of. And it's something that will vary wildly from one organization to another. You're working with Lazada and things are totally DevOps, you're going to have a completely different way of keeping track of versions than if you are working with a UAV company. And Arion Labs was a UAV company. I have shipped products that you cannot touch after you send them out the door. It's a very different way of dealing with things. So versioning, as I'm pretty sure most people here have already sort of understood implicitly, is just a way of assigning a label, a tag, as we talked about a second ago. In GitHub, it doesn't really matter. You are going to label your code. All that we're doing is we're setting up a common nomenclature. What does version 2 mean? What does version lollipop popsicle mean? You know, customer was using the Lazada site or the Shopee site yesterday at 2 p.m. They were using, you know, what's the bundle? I'm going to go through and debug their problem. I have to know which version. This is really important. So okay, I think everybody understands why this is important. You need to understand what software your customers are running, and also you need to know what version you are using, because you will have dependencies. Your code does not exist in isolation. So you need to manage the code that you're using and you need to manage the code that you're putting out. Otherwise, you have chaos. Just FYI, you've probably heard of semantic versioning. This is another way of thinking about it. You've probably heard the formal version of it, which is major, minor, and patch. And the idea is that if you make breaking changes, then you update this first number. Like 1.0.0 to 2.0.0 means you can't use the same interface. Things broke. A minor version should be backwards compatible, but there's some larger differences that might show up. And then patch is I made a bug fix. Now, there's a major problem with this. Let's say I've written, Kareem's awesome library. It does magic for you. It solves the traveling salesman problem in 01 time. Okay, I did this in version 1.0. 1.0 worked so long as your input was exactly what I was expecting, and otherwise it, used exponential time. So okay, I'm making a change. I'm going to give you a patch release 1.0.1. How do you know this doesn't break anything? What guarantees do you have of that? Thoughts? Regression testing, yeah. So I have some regression test maybe that I ran. How do you know that's not going to break your system? It's a trick question. You don't. You have my word as a developer. I don't think this will break your system. Because how do I know what API you're using? How do I know how you're using things? I changed something. Maybe you're relying on the bug that I fixed. And this gets us to Hiram's law. As asymptotically as the number of users of your API goes to infinity, every observable difference is dependent upon by somebody. I don't know how you're using the API. Maybe that thing that I thought was a bug, you relied on, you coded around this idea that my API does this particular thing. Because you observed it, and you said, oh, it does this. Oh, I'll take advantage of it. I'm going to use it in some way. And now I go and I fix that bug, and it breaks your code. Moreover, this is a human-determined label. I have gone through and said, it doesn't break any of the tests that I have. I think this is compatible. I'm assigning this label. It's a heuristic. It's not a guarantee. It's very important to understand that semantic versioning is a label to heuristic. It is not a guarantee. The only thing that guarantees are regression tests and actually running this code. That said, it's very useful. If I'm the developer of this and I understand it very well, and I'm putting my reputation out there and saying, hey, this is 1.0.1, I don't want it to break the planet or I'm going to lose my reputation. Now, maybe in the open source world that matters less, but for certain developers, that matters a lot. So, to consider. There's nothing guaranteed here. Now, is this the only way for you to label your releases? Is this the only way to do software versioning? Yeah? What are some other examples? Anything. What could you use?
I'm not so sure. Maybe just give it a name.
Yeah, just give it a name. Just whatever name you want to today. Tomorrow you give it a different name. There are projects that do that. Actually, does anybody know of some very widely used software that uses names, not quite random, but just use names? Yeah.
JetBrains.
JetBrains? How did they use?
Like a Android Studio. Like they use it'll be like Meerkat and Jellyfish.
Yeah, Meerkat, Jellyfish, so on. They apply quasi-random names. I see a few, yeah. The most common logo on the backs of your laptops here what did they used to use for naming their OS? They did actually, yeah, I guess they used Sequoia, didn't they? Before that, what else did they use? This is all Mac OS. What did Mac OS use for a long time? Big cats. Yeah. What did Android use for a long time? Yeah, snacks, different suites. So yeah, it doesn't really matter so long as it's clear what does the version represent. And there's a bunch of different examples that way. You can go based on commits as well. In what environment might a commit, like just a Git hash, be really useful? If this is something that's rolling over very, very frequently, might this be useful? Yeah. What if you're doing something like DevOps? You're releasing like every 10 minutes, and you need to put something in your server log for what is the version of the software stack that's running. A commit number works. May or may not be the best option. You have to determine that, again, based on your organization and how things work. But a commit option is something that's rolling over very, very fast, is very easy to work with. It's automatic. It internally tracks things, but it doesn't give you a lot more information. You have to go look up what did that commit hash mean. So it's something to think about. You can have assigned identifiers, what we just talked about. It doesn't really matter so long as it's a clear label. Would this work if this is changing every 10 minutes? Not so much. You can't come up with, names like lollipop, marshmallow, nougat, and so on every 10 minutes. That would get a little bit much. But if it's something that comes out every 6 to 12 months, then it makes a little more sense. So, as we mentioned, Android did this. It worked very well for a while. Then they started running out of names, but whatever. Mac OS did this using cats and then Sierra locations or locations in California, because Apple's just very California-centric. Love it or hate it. You can also just use calendar entries. Ubuntu just likes to label things based on the year. I'm not going to point there. The year and the month. So 2404. And this way it becomes just very clear, what does that version of Ubuntu mean? I'm running 22.04. Oh, okay, I know which version that is. That's easy to find. They don't have to think about it. That works for Ubuntu. May not work for other organizations. So which scheme should you use? Is there one best scheme to rule them all? No, there's no best scheme. Depends entirely on the needs of your organization. What is your deployment strategy? Are you doing DevOps? Are you doing packages into an app store? Do you have marketing needs? Do you think engineers are the ones who said, we really should use Cheetah and Puma? I don't think so. El Capitan versus Yosemite, maybe, but yeah. This is pretty clearly driven by marketing. And it's not a bad thing. You need to sell your product. It solves both the engineering problem and the marketing problem at the same time. Which one are you using? Oh, I'm on Mavericks. Makes it, because it does stick in users' brains. Users do not remember this, they will remember this. And then if you need to, on a support call, you get them to actually open up about my Mac and what's the actual version number and so on. Users get it wrong all the time. Whereas this sticks in their brains so much more. So much more helpful. So it seems obvious, but you do have to think about it at an organizational level. And the complication is going to get to what happens when you have a system with multiple components. What do you call a version? How do you label this? How do you keep track of this? So we've just sort of scratched the surface here of how you deal with this. We're going to deal with a lot more when we get to dependency management and so on. Any questions about versioning at this point? Yeah?
Did you say that in this scenario, for this particular aspect, this is often not up to you? Because as you said, the marketing department would want the vending, right?
Yes.
So isn't it technically almost all your hands?
So yes, the question was, is this something up to engineers, or is this something handed down from on high? And it's a bit of both. One of the things through your career, you'll realize that you have to push back in certain areas, and you have to push back in a principled manner. There's a really good question, especially in terms of career advice. If you know something from an engineering perspective is problematic and is going to cost the company money, you need to bring that up. But you need to bring it up in a way that's principled. You need to bring it up in a way that's very clear. This will result in that. If we start releasing things with random names and they're not clear how they line up, we're going to have a support nightmare, and our customers are going to be very dissatisfied. And you need to find a way to bring this up with your higher ups and with other people in the company to make it clear what the problem is and why. And that is a skill you will learn with time. It's actually a very difficult skill, but you'll get there. Good question, really good question. I'm going to get some water. So we're almost an hour in. How are you all feeling? Do we want to keep going for like another 20, 30 minutes, or take a break at this point? I think most of us are still going strong. Let's keep going for another 20, 30 minutes, and then we can take a break. All right, let's get into branching strategies. So, I have to admit, this is what is often listed as like, this is the branching strategy for Git flow. And a lot of people cite this and say, oh, this is how we should do branching. I personally hate this. Any thoughts as to why? Any thoughts as to what's the advantage or disadvantage to this? In fact, there's one big obvious disadvantage just looking at this from the back of the room. Yeah? Yes, it is confusing, it is complicated. It's very difficult to understand what is going on here. Let me walk through a little bit of the idea behind this. So the idea here, and for those watching on video, I'll try and use the mouse for this one. The idea here is that you have this top level, this should be main, by the way. This is very old documentation. Master is an old term, don't use it, switch to main. And the idea is this keeps track of like your very, very high level releases. And even then, like, I'm confused looking at this because there's also a release branch, which we'll get to in a second. So the idea is that you do most of your development on this development trunk. So your engineers are all living here in development land, and they take a development branch, make a few commits, merge it back. And the idea is your engineering team is all on this side. And this is where all the hard work is happening. And then you want to make a release. You take a branch, say this is like your release 0.1 or something like that, and you start hardening it, and you call it a release candidate, and then, oh, we've accepted this to be release 1.0. We bring this back to the main branch and call that release 1.0. We need to make a hotfix, take a branch into hotfix, make some changes, push those to prod if we need to, and then push things back. And that's the idea. Now that we sort of walked through it, how many people feel that this is clear and easy to understand? Not so much. For large organizations, You will get to something that's complicated because you will need to. You will need to separate different groups out, but you have to be very careful to make it clear, going back to one source of truth. If I'm developing, where do I find the code I should be developing on? Do I check out from develop or some feature branch, or do I take it from master? Where do I start from? It has to be very clear. If I'm debugging something, am I looking at the main branch? Am I looking at a hotfix? Am I looking at a release? So at enterprise level, you will get some very complicated setups. Make sure that you understand them, and if not, they have to be simplified. This is the challenge you will often face, is that for enterprise needs, you're going to get pulled to more complexity. But you also need to simplify it as much as possible to make sure people don't misuse it or you don't get chaos. And you will always have that tension pulling you in two directions. Managing that is the hardest thing. I personally much prefer something like this. This is similar to what Google and Facebook do, where you have one trunk. And then you take branches to when you need a little bit of isolation, and the idea is you merge them back, or maybe you leave a tag at some point, but you try as much as possible to keep as close to trunk as you can. My advice, especially for development, avoid long-lived branches. This is one of the themes you will see in Titus Winter and al.'s book, The Google Software Practices. Keep your branches short. And I have seen this over and over and over again. The longer lived your branch is, the more chances are you're going to have problems. If you take a branch for experimentation and it lasts more than like a week, expect you're going to throw it out. If you leave code on an experimental branch for more than a week or two, you are asking for no end of trouble, especially if you're actually at an active organization. If this is your side hobby project or something like that, first off, why are you taking these branches? But also, you can do whatever you want to. It's when you have a team of thousands and you take a branch and you expect other people are not going to make changes that interact with yours, you're going to have a hard time. So once again, what's the best branching strategy? There's not an entirely trick question. What you want is anything that gives you a single source of truth that's consistent and as simple as you can get. The rest of it depends on your organization. Yeah, and this is another one that will depend on your organization. It will oftentimes be decided before you get there. But if you're doing a startup, these are some of the things you need to think about. How do you keep some level of control on your developers while giving them the flexibility to get things done for you? Questions about branching or SCM? Before we get to, yeah?
So like when there's a lot of branches, there's possibly a lot of merge conflicts that occurs. So in your experience, like who is the one that usually has to deal with it?
The person who created the branch. Yeah, so the question was, if there's a lot of branches and developers are taking branches and merging and taking branches and merging and so on, that will create merge conflicts. Yes, absolutely it will. Who is responsible for resolving the conflicts? That is an excellent question, and that is exactly the point of software development practices. It does depend by organization. My experience is, especially if you are using a trunk-oriented strategy where you say, this is where development happens. Whoever takes the branch for whether it's a feature development or a fix or something like that, they are ultimately the one responsible for keeping in sync, and it's purposefully to keep your branches short-lived. Do not expect other people to keep in sync with you. You have to keep in sync with trunk. That's what I've seen as the best practice, but it will depend on the organization. Because maybe you have some super critical code that you want to make sure stays in a certain state, maybe you will change that and say that, if somebody implements a feature, they're responsible for making sure that it stays in sync. It varies. In general, I've found whoever takes the branch, they are responsible for keeping it in sync until it gets merged.
So
Yeah.
for like a follow-up, because I feel that there are scenarios where the person is merging into the main branch,
Yeah.
right? They accidentally delete an important part of code in some sort of like junior mistakes.
Yes.
Yeah. So like how do we?
So in that case, it's more, so the question was if somebody takes a branch and then deletes a section of code and then merges it, who's responsible for fixing that? That's less of a merge conflict and much more of, there was a, that was a junior error and they're responsible for fixing things, for sure. That said, your SCM tool should support that fairly well. Like undoing a commit, rolling something back, should allow you to have, like if you took a branch, somebody else screwed up trunk and then undid it, your SCM tool should then allow you to merge back in again properly. If not, you've got problems with your SCM tool. And that's, again, organizationally, you have to deal with that. Yeah. Yep.
Is the practice of having a staging branch widespread in bigger tech companies?
Yes. Staging is something that definitely happens frequently. Again, it very much depends on the organization. Like Google did not. There was no staging branch in Google. There was no way we could have it. It was way too big. But at a lot of tech companies, staging will essentially act a little bit closer to like a release branch. So the idea being that maybe if you're doing something more DevOpsy, you'll have like a develop branch, and you'll have a staging branch, and then you'll have like the actual release to production branch. The way Google did a lot of things is that the code would be entirely in trunk, and then they use configurations to enable and disable certain features. And so that was a different way of managing things. So yeah, there are no end of strategies here. But yeah, good question. Other questions about release branches and versioning? All right. Let's talk about dependencies. This is probably the most important and most difficult part of software engineering. First off, what do we mean by dependencies? What is a dependency? Yep.
Like libraries and stuff that either someone else or someone outside your organization has developed as like a helper for your code, and you use it in your content. You don't have to write all that.
Yeah, so an external library that does something useful that you use in your code so that you don't have to rewrite that code. Yeah, external libraries, really good example. Is that the only form of dependency? Other examples?
You can think of another team to deliver their output.
Yep, so internal dependency. So another piece of code, say you're doing the front end and they're doing like the back end kind of thing. Yep. Other examples of dependencies, yep.
Like I don't know the technical term, like source of information, like an API like Google Maps.
Yeah. So an information source, like a data source. Yeah.
Yeah, library, online library, or
Yeah. How does that differ from the library you mentioned a moment ago? What's the big difference?
Sorry, when I say library, I'm thinking of books and stuff. Like I just
Yeah.
example.
Yeah, no, but there's like Google Maps versus a library that, a code library. What's the big difference between those two? When do you access them? Somebody help Luke out. What's the big difference between like a Google Maps API that maybe your app uses versus like a text parsing? Yeah.
So maybe the like a code library can be like compiled into your project. Maps API, you can't just download it to access it.
Yeah.
While capturing it.
Yeah. Compile time versus runtime. Big difference between something that you compile that's available at compile time versus something that has to be available at runtime. Big difference between those two. Other examples of dependencies? I mean, we talked about data dependencies. Maybe it's a data source of some sort. Any other examples?
Sorry,
Yeah.
Are you saying that the Google Maps API is the one that you're dealing with?
Yeah, Google Maps API or any RESTful API that way is an example of a runtime dependency, something that has to be available at runtime. It doesn't have to be available at compile time. I mean, it's nice if it is, but not needed. Versus something compile time like a fixed library. Yeah. These are all examples of dependencies. And essentially, dependencies, anything that's needed that isn't in your direct control. So the data example is a really good one. That you will have data pieces that are needed for your code to work. I've run into that in so many different applications. So yeah, also build tools. You know, if you're building in Java, you need the Java compiler, you need a JDK. If you don't have the JDK in your system, are you going to be able to build? What about like, you know, static analyzers and other tools? Anything that's not in your direct control. Modern software has a lot of dependencies. I think I asked earlier who has developed with React or Angular or any of these really big JavaScript runtimes. I was building an app, just a side hobby app in React Native last year. I was trying to do better than Anki, and in some ways I did. In some ways my app was better than Anki. In other ways it was worse. But this is just the dependency graph for the React Native. Not even like all the things you need for an app, just the React Native package alone. And it developed this huge constellation. It's hundreds of megabytes just for React Native alone. This is, I think, NUnit. I found this one as just a random image on the internet, which I was going to use until I could build my own. So take this with a grain of salt. I don't know if this is real. This one I actually developed. So I'm pretty certain it's correct, and I can tell you for sure I could do the LS of my project, and it's about that size. But yeah, we have a lot of dependencies. This is both a good and a bad thing. Why is something like React Native, first off, why is it a good thing? Why is React Native useful at all? Why would I bother using it? Any thoughts? Why does anybody use any of these frameworks? Yeah. It collects a whole bunch of things that you don't need to figure out how to do for you and does it. It's like, oh, I want to build a mobile app. Okay, I plunk this in, and hey, I have a mobile app. I can just add a little bit of JavaScript and I have my app. What's the downside? Especially the downside of these huge dependency graphs. For anybody who's actually... Yes. When things don't work. Was that what you were going to go with, Luke? Or?
Yeah, I was going to say,
Yeah. Lots of failure points. That's exactly it. It produces a huge surface for bugs to appear. What happens if one dependency updates and breaks another? For anybody who has tried updating React Native, you have felt this pain. Because I have gone through it many times. I gave up on that app because I just couldn't maintain it. I was building it primarily for myself and a few friends and other people trying to do language learning, and I had to give up. Because just in the past year or two, React Native has gone forward so many versions, and updating it meant that I had to walk all of these dependencies, and this one updates to here, but it's not compatible to this, it's not compatible to that, and this one has to be downgraded. It was a nightmare. It was an absolute nightmare, and I've given up on React Native largely for this reason. It got insane. Yeah? Oh, it's a really good question. Why do I have to update my app at all? And this gets to a really important concept in software engineering, that you can't ever stand still. For the Apple App Store, I would have to build and release every 1 to 3 months. And so Xcode on my laptop would auto-update. I'd either have to fix my whole laptop at a version, or my app would break. And I eventually decided that the app wasn't worth it. I need my laptop up to date. I had to be updating my laptop. Yeah? There's a question here? No? Okay. So this is the dependency hell that you run into in a nutshell. Diamond dependencies, as they're also called. You have your project. Here, I'll use this one so that people on the video can see. So you have your project. You depend on 2 libraries. And one of them, say library A, no, sorry, the other way around. Library B updates to version 2 of some other dependency library and says, nope, this new version of library B requires library D version 2 and will not work with 1.0. Library A requires 1.0 and will not work with 2.0. What do you do? Give up and become a farmer. No, you have to fix one or the other. This is exactly what I ran into with React Native. This is dependency hell. Package managers will help with this to a certain extent, but this is what we run into all of the time. So all of this, actually no, there's more. I forgot about this. Thinking about this in more depth, what do you do when something you depend on, one of those packages, updates in a way that breaks your code? They went from 1.0 to 1.1, and you were depending on some little thing in their code at 1.0. What could you do at this point? Yep.
Use the specific version, don't have that.
Yeah. How? You have your code in SCM. There's their version on the web. How do you make sure that you use 1.0? Package manager. So you have to specify for some package manager. And if you remember package managers, what would you normally do in a package manager to specify that? Yeah, there's a packages.lock file. Yeah. So there's package management configuration files. What's another way you could get the same result? Now, let's say this is a piece of a library that's super important to your code. What other ways could you deal with this? Other than using npm or yarn? Yeah. Fork and maintain it yourself. Yes. So you could make your own repo, maintain it in a spot, and then how would you make sure that your code uses that forked repo? Yeah, so in the package manager, more straightforward method. Yeah, integrate directly in your code that it points to that repo, not even using a package manager. Something even more direct than that. Really, really important library that doesn't matter how often it changes. Something really important that you need to maintain in lockstep with your code. Yeah, just put it in your code. Put it in your own repo. So you have your repo with your SCM for your project, put it straight inside. Another method. So even beyond this, how would you check that the dependency updates and is correct? What do you do? Yeah. If you open a branch, so are you assuming that we have our own repo, or where is this branch? Yeah. So I think you're assuming a package manager. So you're going to take your code, take your project, take a branch, update the version number listed in your package manager, and then test it. How do you test it? How do you make sure it's correct? Like integration tests? Yeah. You could have some sort of integration test. You could have some sort of QA and so on. But my point here is you have to do something. You can't just say, oh, we'll just import all dependencies and YOLO. You have to do incoming inspections of your dependencies. Your dependencies get updated. There's no sitting still. I'm hoping that this has been covered, that you can't stay still. Your dependencies are going to update. You need to move forward, but you need to do it in a controlled manner. So you need, whether it's integration tests, software QA, whatever it is, you have to have some way to check. What do you do if they have a critical bug that they either can't or won't fix? You know, maybe this is some open source library and nobody exists to develop it anymore. You know, you started this project 5 years ago and it's critical. What do you do? Or maybe they decided, actually, that bug is a feature to them. They don't want to change that. And for you, this is absolutely blocking. It is destroying your ability to generate revenue. You have to change this library. You can't wrap it. You have to change the library. What do you do? Yeah? Yeah, you take your forked repo and you make a change. Or if it's in your repo, you change it. What happens if they deprecate a feature? They decide that, you know, we started this project as a video player, but we really don't want to do video anymore. It's now just, you know, an ML for video project. And the actual playing, we don't do that anymore. And you kind of need it as a video player as part of your app. Same thing again. You can fork and keep going on your own. You can keep in your repo. You can do whatever you need to. Just realize you're on your own at this point. Yeah. What do you do if they depend on an out-of-date library? Most of these, the solution is you have to maintain it yourself, or you have to switch to another dependency. The bottom line is that you must manage your dependencies. You cannot just expect that, oh, there's this dependency, even if it's a commercial dependency. Actually, oftentimes a commercial dependency is much, much worse because they don't give you the code. You have zero ability to fix anything yourself. You have zero ability to inspect anything yourself. And so it's just trust us, this works. What do you do if they update their code in such a way that they've planted a malicious backdoor? That's a problem with commercial dependencies, commercial software. So these are just some of my suggestions. We've talked about pretty much all of these. If it is super, super critical, just put it in your library. Put it in your app somewhere in your code base. If it's that important, you manage it like it's your own code. And you deal with the merges and so on yourself. If it's something a little more medium-sized, especially if it's being changed moderately frequently, fork your own repo. If it's a large, well-established library, especially one that gets updated frequently, this is a Git feature called submodule, recommended. Look at runtime things like lock files, containers, and so on. Package managers can be helpful. Bottom line, as with everything else, is you have to figure out what works for your project and your organization, but keep these questions in mind. Don't just assume, oh, look, there's a library for this. My problem is solved. Realize that dependency is a liability. And you want to limit your liability. You're having thousands of packages is an extreme liability. It can be extremely useful. Building, you know, I would not want to try and write a mobile app today, writing everything from scratch. You know, once upon a time, somebody wrote Railroad Tycoon in assembly from scratch. It's just one of the most mind-boggling things I can think of, but I can't imagine trying to do that today. It's just, yeah. But sometimes people can, but it may not be very efficient. So keep these things in mind when it comes to dependencies. They help you, but they're a liability. All code is a liability. Beware of it. I think with that, we're at like an hour and a half. Is now a good time for a break? We take a 5-minute break and come back? Yeah. All right. So it's exactly 3:30. We'll be back here at 3:35. Test, test. There we go. Alrighty, let's get started again. We're now going to talk about deprecation. I think everybody knows essentially what deprecation is, but let's start with just some motivation. You have some legacy code. It did things a certain way. You know, let's say this code dates from back before I was a child, and it has specifics for chopping a file up into 1.44 megabytes for a floppy disk. Do you think you still need that code around today? Believe it or not, in some parts of the world, they might still use floppy disks. So what we mean by deprecation is, how do we remove code or features we don't need anymore? Simply dropping it out in the middle, you don't know what impact that's going to have. That leads to chaos. And so the goal with deprecation is to give us an orderly way to move forward. On the one hand, we don't want to just hang on to this ancient code for dealing with floppy disks. On the other hand, we want to do things in an orderly manner. It's probably one of the most important things in terms of enterprise systems. And this, again, is going to vary a lot. If you're dealing with an embedded system like the drones that I used to work with, it was a lot easier to deprecate code. Because I could just say, okay, going forward from this version of the machine onwards, we're cutting out this code and we put in this and we test it on this machine. And if it works in this machine, we ship that machine. I don't have to worry so much about deprecation. But if you're building some library that gets used by 1 billion people around the world in all kinds of different configurations, let's say it's something that's in the middle of Android, do you think you have to worry about deprecation? Yeah. You're dealing with something in the middle of Android, you have a lot of systems that you have to deal with. And generally, the more critical your system is, the more this is important to you. On both sides. Because if you don't ever deprecate something and it's in the middle of Android, what happens every year the system is out there? More people are going to use this deprecated portion of your code. And it's also one of the things that's least well done. So this is a quote from Google in the middle of the Google Suite book, which I'll reference at the end. But doing it properly, Google is actually famous for doing this very often at a product level. And even more, if you work internally, you'll see how often they do this internally. Sometimes we get it right, and sometimes we don't. This is one of the best run software engineering groups in the business, and they struggle with this. So know that this is something that will affect you. So we've talked about why. It's not related to age necessarily. I mean, he used the floppy disk example just because it's obvious, but sometimes you'll come up with something in one release, and next release you realize you got it wrong. That was not the right way to do things. We need to get rid of this. How do you do that? And it's difficult for a lot of different reasons. Migration can be expensive. You know, you came up with this feature 5 years ago. You have a bunch of customers that are using it. You say, okay, we want to get rid of this feature. Like, no, we're using this, and we have millions of dollars running through our pipeline that use this. We don't want to take the risk, even if it seems obvious. To you as an engineer, it seems obvious you can remove this chunk and everything else will work just fine. People will be risk averse. And you need to convince them this is safe. That's one of the big differences, the big changes that you will need to work through. So who's seen something like this in Java? Y'all are working in Java, right? Or have seen some level of Java? Yeah? I'll just ask you, where is the deprecation here? It's just this little tag. Java makes this easy. Does all languages have this? Do all languages have a deprecation at deprecation tag? No. Does anybody work in Rust? Anybody know, is there a deprecation tag in Rust? I think there is, but I don't remember how it works. I've only played with Rust a little bit. I know C by default does not have one. that I recall, at least old school C, C++ might, if you add some things to it. So this is very much language dependent. And what's this going to do? I mean, if I drop that in, does that break all of your code? No. What does it do? Yeah, it'll give you, it's an advisory. It just says, hey, this has been deprecated. You might want to think about changing. It's really all that it does. So it'll just give you something here. It says, hey, by the way, this uses a deprecated API. And you can use different tools to scan for this and so on. Try playing with it. How many of you have seen deprecation warnings in your code already? Yeah. How many of you actually pay attention to them or do anything? This is the danger of it, the downside. If you deprecate something in your code, what do you think the chances are that your clients are going to change anything? Any thoughts? Who thinks it's above 70% chance that your customers are going to change anything? Hands up if you think it's above 40%. Yeah, I think it's pretty negligible. So, yeah, deprecation warnings will help prevent new uses, but there's some downsides. Oftentimes people just ignore them. This is what you could do to make it a little more actionable. So this was a good example of what not to do. Hey, I deprecated calculate. Well, okay. Oh, and it does list the option here. So that's actually what you should do, is say that. But it would be nice if you actually included it in your deprecation warning. Say, hey, go use this. Again, that depends on your tools. What do your tools support? Do you have the ability to do that? Can you automatically? I want you to imagine for a moment if you were working at, let's say you're at Google. Google famously has a monorepo. We have one massive repository. So let's say I need to make this change. In addition to deprecating it, if I have access to all of the source code at Google, what could I do if I wanted to make sure that this happened? Yeah, I could check every instance. What could I do even further than that? Much, much further than that. What could I do? And this is not evil, by the way. It depends a lot. We talked about how the rules are organization dependent. At Google, this is encouraged. It's not just questionable. No, it's encouraged to do this. What could I do if I know something is deprecated in the code base and we should be moving things up to some new interface, say whatever this interface. What's that? Yeah. No. What could I do? I have access to the whole code base. Yeah, find and replace. Find and replace. Go and make the change. And I wouldn't necessarily commit it. What I would do is I would find the change, make the change either on a branch or some local copy or something, test it. And then I would send that change request to the person who owns that code. And that is encouraged at Google. I wouldn't necessarily change it like under the rug on them. It's like, oh, whoops, we're changing the code on you. But I would go through and say, hey, this is deprecated. To help you out, here is a change. I've updated your code to use the new interface. Here's how it should be done. And that's encouraged at Google. That's considered very, very googly, if you will. But again, that depends on the organization. I think at Microsoft that would be less encouraged. But you would be encouraged to document and say, hey, here's how you do it, and push organizations to do things. So yeah, there are new features in Java where you can say, hey, this is now scheduled for removal. Again, this depends on your tooling. This is now a warning or something. Hey, listen, we are really going to change this on you. For real. For real. And then you get to like a compulsory level where you say, hey, you have to do this by this deadline. This really gets to organizational policies and organizational cultures. Do you pay attention to these things? Do you not? Do you push them on other people? Do you go and make the change for them? What's available to you? You're going to see that this is going to depend a lot on what's in your organization and what power do you have or what's considered acceptable. Because maybe at your org it's not acceptable for me to give you a change request changing your own code. That's considered stepping on somebody else's toes. Maybe that's considered a nice service. It varies. Sometimes you'll deprecate even during the design process. Again, this depends on what are you designing. If you're designing a nuclear power plant, you are designing for eventually this power plant is going to get torn down. You know that at some point this has to be decommissioned. Software is rarely do we get to this point, but we want to make it easy for people to move on to other things. So I don't want to get too far into depth and deprecation. It's just a communication to other people depending on your software, and you will be on the receiving end of this. We've talked mostly about this in terms of dependencies. Are there any questions about deprecation? Yeah?
So for the code revision and Google, like changes for others, what about Hiram's law? What about like if I make changes, things crash?
Very good question. What about Hiram's law? What about if I deprecate something and then I make these change and then I push it and it crashes? Before I would send somebody a change request of any sort, I would have to test this. And actually Google's philosophy, specifically for Google, is that everything must have tests. And so what that allows me to do as somebody who's producing one library and you produce the system that uses it, is I can take your code, change the way that you interact with this library, run all of the tests. And the idea is that if I run these tests, then that is as far as I need to go to say, hey, this works correctly with yours. If it breaks those tests, that's on me to fix. And actually, much beyond that, they have a live at head philosophy. If you search out Titus Winter's talk, Live at Head, he gets to exactly this point. Now that works for Google. It would not work for other organizations. That's probably the biggest criticism of the live at head philosophy and the Google SWE book, is that it works for a very particular set of organizational assumptions. It does not work for others. Yeah, great question. Other questions about deprecation? All right. Let's talk about code review. Code review is a lot more interesting. Code review is, to me, when we really get into some of the people practices of software. So, a hopefully not hypothetical question. You've developed some new feature. You've written the code for it. It works on your machine. Can you just send it? Just ship it. What do you need to do? Any thoughts? Yeah. Yeah, so you've tested on your machine. Okay. What else? Yeah. This gets to code quality. You will always have pressure to just ship things and get things out the door. But if you introduce some bug, this is going to be a problem. So what's the simplest thing that you can do? Just get somebody else to look at the code. And it's surprisingly simple, and yet it's been shown to work. It's been shown that formal reviews catch an enormous amount of defects. Now, quick caveat, these numbers have been debated. There's evidence going back and forth that sometimes it's closer to 30, sometimes closer to 70. It doesn't really matter whether it's 40 or 60. It catches a significant percentage of defects. Not 100%, but a lot more than zero. So it's a simple thing that you can do to make sure code is of high quality. But even more than that, Let's say that you introduce some code, and I look at it and I go, hey, wait a second, we're planning a new feature that's going to be at odds of this next month. I can look at this and say, wait a second, this is not going to be maintainable. What happens when we need to change the rules? What happens when we need to add another piece to this? And so on. Now at least we can talk about it. And say, okay, I see what you're doing with this feature, but we need some ability to change the rules without recompiling the code, so we need to add this or we need to change that. We can talk about maintainability. And this is absolutely true in my experience, that the majority of the comments, the things that go back and forth in code reviews, are not to do with, oh, this is a bug or this is a problem. It's, how will this work in the future? What will happen when the next person goes to read this code? And you get a lot of other benefits. I can say with absolute confidence that through my experience, whether at Google or Arion or ClearPath or wherever, reviewing code was always beneficial. Reviewing other people's code would get me to understand what they're doing. I would learn their techniques. I would learn the state of the software. I would learn things every single review that I did. Getting other people to review my code. At Google, when I first arrived, I was like, oh, why do I have to do this? And this is so painful. And after, 6 months to a year in, I realized I was bottlenecking myself. I was bottlenecking my own growth. And I realized that this was the best thing. I got other people to look at my code, and they would give me advice for how to do things better, or I would show it, even showing it to more junior engineers. They would learn by reviewing my code how to code better themselves. And that's assuming they didn't find things that I had missed, which was often the case because I was doing a lot of different work. They would say, hey, what about this? Like, oh, hey, you're right. And then I would go through and I'd fix things because oftentimes the junior engineers were looking at things at a different level than I was looking at, and they would spot things. So you get a lot of side benefits reviewing code. My advice, especially when you're newer in an organization, review a lot of code. Review other people's code, get your code reviewed, even if it's not required. You will learn a lot more and you'll have much higher quality code. That said, speed. Speed is critical. Somebody asks you for a review and you know you're overwhelmed and you will not look at it for a week, tell them. Tell them, like, listen, I really want to review your code, but I will not be able to get to it this week. You don't want to hold them up. If you say, oh, yeah, I'll get your code, send me your CL, I'll look at it, and you sit on it, great way to sabotage your organization. Don't do it. Speed is important. Review time goes up exponentially with the size of the review. Think of it yourself. You get a code review in, somebody sends you a pull request on GitHub, whatever, and it's like 10 lines. How long does it take you? 100 lines. How long does it take you? 1,000 lines. I don't know about you, but for me, a 10-line review, a few minutes. Unless it's like code I absolutely don't understand. 100 lines? Something under an hour. 1,000 lines? That's the whole week. And even like something a few hundred lines, depending on how complicated it is, that can be several days. You have to think about what is the trade-off between speed and thoroughness at your organization. It is not a one-for-one trade-off, but there is always a trade-off. If you go through every single line in excruciating detail and have to understand everything, it's going to be a very long review. In some places, that's what they want. Google actually does emphasize like line-by-line reviews, like you have to understand every single line. It doesn't always happen in practice, but they push for that. But other places, it's like go through it and see are there any major problems. It also depends on the situation. You know, if this is something that's running on Google's critical web infrastructure that's serving 1,000 queries a second, you might want to go through that with a fine-tooth comb. If this is some new feature for an app that's experimental, then maybe you can be a little more lax. You have to decide. You have to figure out where things are. But realize that speed is always important. Let's talk about some practice. First off, who's been through pull requests and reviews here? Yeah, a few people. Before I go on to the next set of slides, what are some things that you found were helpful, either on the receiving end or when you were sending, either receiving code reviews or sending code reviews to somebody else? Things that made a difference to you. Any advice you would have for somebody? Let's say somebody's going to send you a pull request. What helps you in terms of making it easy to review? Sorry, say again? Comments? Like comments in the code? Yeah, so something that's well commented, easy to read kind of thing. Yeah. Code coverage, like test coverage kind of thing? Yeah, so some indication of test coverage. Yeah. The commit message. What about the commit message? Sorry, a little louder. Enough context for the person reviewing to understand the change. That's absolutely critical. Understanding what's being changed and why. Yes, really, really good point. That assumes something. There's an assumption being made in a few of these. It's assuming a level of clarity. If your change is changing multiple things at the same time, is that a good change? No. What do you want the change to be? A single logical unit. You want it to be clear and concise. I am changing X to accomplish Y. I'm not doing Z, I'm not doing W, I'm not doing other things. It's doing this one thing. That's absolutely critical. I think we've already covered most of what I want to say. Keep your reviews small and focused with good descriptions, exactly what we just talked about. Choose the right reviewers. In your organization, you're going to have a number of people who are experts in different areas. This is also a reason to keep things small and focused. If you have one big change that covers a number of areas, you have to get a bunch of different people to review it. You make a small change to one piece, you get one person to review it. You want to balance getting good feedback with keeping the number of reviewers to a minimum. So don't put the whole organization on your review, but obviously include the people that you need to get their feedback on. Beware of your own inertia, especially as more junior developers. I mean, I got to Google after over 10 years in industry. I thought, I'm a fairly accomplished engineer. I know what I'm doing. This is going to be easy. I rock out, submit a code review and get, yeah, no, this way is really not the way that we do things here. We do it this way, and there's this, and there's this. Oh, we have to do all this. This is just like so much stuff for a little bit of style. Why? And I would push back and push back. And eventually I said, no. If somebody at Google is giving you feedback as to, hey, here's the better way to do this, if you don't have a clear reason not to, make the change. Get over your own inertia. Especially the more junior the developer, the more inertia there is. Senior developers are the ones who look at it and say, yeah, that's a good idea. Here's the update. And you move forward fast. It is faster for you to make the change than to push back on it. That said, push back if you need to. You look at it and say, no, wait, that's going to cause a problem with this. No, we coded this way for this reason. Do push back and make it clear why. Don't just say, no, we can't do that. It's, we coded it this way for this. How about, handling this problem this way? Look for a path forward. And try to learn as much as you can from any feedback you receive. Not just for this particular change, but how you can improve your coding in general. critique reviews are probably the single most valuable way to learn. It certainly was for me at Google. When you are reviewing, push back on these same things. Like if somebody sends you a CR or a pull request and it's got, oh my gosh, we're changing like half the world, be like, bro, why? Focus your changes. Bring this down. If it's not well commented, the change isn't well described, it's overly broad, push back and say, no. Get this focused. You need to make your commits tighter. Remember, you're on the same team. Attack the code, not the person. A lot of people get their egos involved, and this happens on both sides. So the inertia thing that I mentioned, this is also ego. When you are looking at the code of somebody, make sure you are attacking the code. You want to make the code the best there is. Leave aside how you feel about the person. Leave aside any opinion that way. If something doesn't make sense to you, start with a question. Because maybe there's a very good reason they're coding it the way they did. They know that in Android, this particular data point comes in and it has a 90% chance of being in this particular configuration, which is going to crash if we don't do it this way. But they didn't comment that. You don't know why. But it's like, this is weird. What's going on? Say, hey, what's going on? Why is this written this way? And maybe they'll come back with that. And then you say, okay, we should comment this, or we should make it clearer that this is what this check is doing. Or maybe they'll kind of say, oh yeah, we thought it was going to be this way, but then we tested it out and we discovered X, Y, and Z, and none of this actually works this way. And so this is just left over. So say, okay, could you rewrite that so that you don't go through this crazy way of analyzing this data? Oh, yeah, okay. And then we'll go through and fix it. Much better than going like, WTF? So point out the problems you see, suggest solutions. If it doesn't make sense, ask questions. And don't stop at the normal case. Senior developers are always looking at what happens when things fail, what happens in exceptional circumstances, what happens when things need to be changed in the future, how will your code adapt? While at the same time balancing, have you all heard of the Yagni principle? Who here knows what Yagni, Y-A-G-N-I, yeah? Do you remember what Yagni stands for? You ain't gonna need it. Exactly. So you need to be able to adapt to change in the future without coding for things you don't need. And that's what senior engineers are always trying to do. And lastly, be responsive, but balanced. Point out things with certain severities. You know, Google has a whole lexicon of, you know, this is a nitpick, this is an FYI, no, this is really important. And that way you communicate clearly what your expectations are. Yeah. And be honest with that. You know, if you look at something and say, I really wouldn't code it that way. I don't like that particular name, but it doesn't really matter. You just sort of put nit, like, could you come up with a better name? Then they can choose to ignore that. Google has a bunch of documents on engineering practices. So ironically, this engineering practices page is all just about code reviews. I highly recommend reading this as a good guide to code reviewing. These slides will be made available. These links will be made available to you as well. But this guide is really good, just for code reviews. Questions before we dive into examples? Yeah.
Can I give you this situation? Could you tell me how you give a code review?
Mm-hmm.
Let's say there is a variable in someone's code
Mm-hmm.
that counts the number of green apples.
Yeah.
And that person names the variable as apple. Then, and you think that this better be changed as green apple since that is the most important. How would you?
So the question was, there's a method that's counting the number of green apples, and the variable name is just apples, which you find confusing. And how would you leave a comment to that? That's tricky one. Is there a particular reason they called it apples that you can see?
Because apples, they could become red apples as well.
Yeah. No, but can you see a reason why they called it apples? Like, is it just like a short version? Like, yeah. Yeah. So I would probably comment something like, please use a more descriptive name like green apples. I would just keep it short, to the point, and just like, please use X instead of Y. Or with an example, and then leave them to handle it. Yeah. Usually I would not, for something that straightforward, I would not write more than I need to, because it's just time is money. Let's just get to the point. If it's something where I think there could be an alternate reason, then I might phrase it like, hey, why is this only called apples, or what's going on here? Yeah. But I will oftentimes do that with variable names that are like X, T1, T2, I, J, and so on. Sometimes, for loop counters, you want the shortest name possible, because it's very clear and it's very tight. When it's within a few lines, and it's very clear that this is just an index, I actually prefer something like I, myself. Again, this depends on the organizational style and culture. But if it goes beyond a few lines, for me, that's like, if it's more than about 3-4 lines, it better be descriptive. Yeah. So good question. Other questions about code reviews? Yeah. We are at 4 o'clock. I have a couple of examples. Let's see if they will load. Some of you have seen code requests or pull requests, so you've seen this already. Oh no. Would you mind if I brought up the SQL Lancer pull request we went through? Hopefully that will load. So I actually contributed a little bit of code to SQL Lancer, not a ton, and I'm hoping that this will show up. So this just gives you an idea of what does it usually look like. Usually it gives you a view of like the code and what's changed, so you'll get some sort of a diff. This one I was adding a bunch of files. Usually you would want to have something a little more fine-grained with, these are changes. And this is a really good example. Manuel, Professor Rigger was asking, this is really SQLite specific. And we got into a discussion of trying to replace this and discovered that there's actually some limitations of Java. Throwables can't be generic. So that meant that our method for doing this couldn't work. There were other comments. Yeah, so Manuel commented that, there was some code that was in here that was really quite hacky, and I think I did actually end up updating it. So this is another good example of beware your own inertia. And it was actually mostly, I didn't understand how to make this code better. It was hacky. I looked at it and went, I acknowledge it's hacky. How do we make this better? And so this is a good example of using the code review process to improve things. So discussing how do things move forward in a way that makes things better. Do we have other examples? So it's just a way of having a conversation around a set of code. What you'll also see very often, especially with Google's tools, is that automated tools will flag things. So you'll have style guides or things that say, hey, this may be an issue in terms of style. And it'll actually flag things in the coding tool, and then you can actually comment on that as a reviewer, say, hey, yeah, you need to fix this, or no, this one you can ignore. Are there other examples in here? Yeah, I'd have to log in to have a look at the other one. The other one had a lot more fine-grained examples. We'll have to come back to that. Any other questions about code reviews? So if I could, one piece of advice for you all in your projects, try to do at least one code review in your project, just to get through the habit of what does it mean to somebody else look at your code? What does it mean to look at somebody else's code? I know It's middle of the semester, everybody's busy, you're going to be like, oh my God, we got to get this project out and study for finals and everything. There's always a ton to do. There will always be a ton to do. Even when you become like, professional SWE and so on, you will have pull requests and code reviews pile up and you'll have to get through them. Try to go through it now so you learn how this goes. Yeah?
Just a quick note, because there is also currently an opportunity. So SQL we are participating in the Google Summer Code project. And now is the period where a lot of open source contributors try to pull requests and make changes. And given that we now have some background in SQL, we can actually also participate in the process if you want and practice some of the things that you currently. Like you can see many of the entry patterns that you find out for example, changes that are unrelated or that are quite large or something. If you want, you can just participate in the process.
So yes, sign up to SQL Answer. Have a look at some of the pull requests that come through. If you have experience with Java and SQL Answer, it's a great way to get into it. SQL Answer is a really cool tool, and it is used by a lot of organizations. So a good opportunity to get more exposure to all of this, or any other open source project. Look for pull requests you can review. Look for things that you can fix. Really good examples. Let's see, come back here. Any other questions about code reviews before we move on? All right, we've got about 45 minutes. There's only a few topics left. Okay, continuing with our hopefully not hypothetical scenario. You have written your code, and now you've gotten it reviewed. Can you ship it? What else do you need to do? So somebody else has looked at your code. It works on your machine. When you run the test, the unit tests on your machine, things work. Can you just send this out to customers? What else might you want to do?
Testing environment.
Sorry? Try different tests.
Even testing environment.
Yeah, so try it in different testing environments. I didn't catch what you said.
User acceptance.
User acceptance testing. What is a user acceptance test?
Whether it's like the evaluation of it, that you make sure that what you're trying to do is what is needed.
Yeah. So something where you try to simulate the user and see, does this do what they want you to do? That is exactly software QA. Just as you would not ship a physical product without verifying its quality somehow, you're not going to ship a software product without verifying some level of quality. Software QA is just the umbrella term for whatever you have to do before it gets to customers. Now notice that this is very broad. It's not just testing. Hopefully, you ran some tests before you committed the code in the first place, or you would not be committing the code. Hopefully, your reviewers pushed you and said, hey, where are the tests for this? Check to make sure, does this pass any tests? This is more than just testing. Now, testing can be part of QA. Hopefully, you have integration tests and so on, but it's a lot more than that. So how do you do this? Varies a lot by organization. What we would do at Google was completely different from the UAV company. UAV company, we eventually had, not eventually, very early in the company, we had a policy where we had to actually fly our code at least once. Now, this was very early startup days, you can tell. It's like, hey, we should actually fly this code. Yes. We would have to force our engineers to make sure that that package, the whole package, was tested. Because we would oftentimes, oh, I tested this piece, and I tested this piece, and I tested this piece. We eventually started, within, I think, the first year of the company having, I think within the first year of actually having any customers, having to do formal QA because it got embarrassing. We once or twice with very early customers shipped them code that wouldn't actually take off. That was as embarrassing as you could get. And then we said, okay, right, QA. We actually hired somebody, a friend of the founders, to just take this code from our build system, put it onto this quadcopter, and then go outside and actually fly it. Even if it's Canadian winter, this has to get flown. And we would make sure we did that at least once before sending it to customers. No matter how many individual tests, we had to put everything together. And obviously it's different, completely different from how we do things at Google. Google had a totally different environment. And as I said, they typically build the whole monorepo together and then do a staged rollout of the code and then a staged rollout of the configuration. And they would do this in an absolutely enormous rollout, where they would have all kinds of cells across data centers worldwide, very different set of requirements. So you have to figure out what are your expectations. Figure out who does QA. And this gets us to our usual joke. This is an old joke. How do you figure out what a customer is actually going to do? You know, your QA engineer says, oh, I'm going to order a beer. I'm going to order -1 beers. I'm going to order a random string. Your customer walks in and asks where the bathroom is. Hopefully, your product does not explode. But how do you know this? You have to talk to your customers. You have to figure out what's going on. And this is why I say it's not just testing. You may have tested this API for ordering beers a million different ways, but if you don't actually have somebody say, hey, where's the bathroom in this thing? So yeah, you have to simulate the customer. How many of you have experienced products where it works, all the functions work, but you can't figure out how to get it to do what you want? Yeah, I'm sure you've all experienced this. Let me ask you this. I put the example of controls on there. You're doing a 3D video game. You have your typical joystick or something like that. You're going forward, and you press down on the joystick or the joypad. Which way, if you're doing like a 3D video game, which way should it go? I'm going this way, should it go this way, should it go that way? Yeah. I'm glad you're all trying this out. It's a trick question. There is no correct answer. For many of you all, I saw you pointing down. You know, if you're taking a joypad and you go down, you expect to go down. I'm trained as a pilot. What happens if I take a stick or a yoke and I go like this, if I'm flying my airplane? The airplane goes like that. Gets even worse with a mouse. Because a mouse, most people think down is down. For me, I'm pulling down as I'm doing this. And a lot of video games work completely backwards for me. And yet this is a very human thing. Humans have the ability to adapt. There's a really cool engineering channel on YouTube called Smarter Every Day. And he has one about the impossible bicycle. You've seen Smarter Every Day in the back. You've seen Smarter Every Day? You seen him? Yeah? Do you remember the impossible bicycle? It's a bicycle that's impossible to ride. Yeah. So he set up this bicycle. Somebody decided to challenge him. This guy's really fun. And somebody decided to challenge him. I'm going to make a bicycle you can't ride. And it's an engineering challenge. He's set up this bicycle so that you turn the handlebars this way, the wheel goes this way. The wheel turns backwards. So, and yeah, he's absolutely floored. He's like, this should be easy. He'll hop on and he'll figure it out. No, he could not ride this bicycle. Except he took, I can't remember if it was a week or a month or something like that, and he just rode and rode and rode, and then one day it clicked. And he started riding this bicycle with a backwards steering. And he was able to ride it perfectly. One problem. He went back to ride a normal bicycle. He couldn't ride a normal bicycle anymore. It was just gone until he practiced and practiced, and then he was able to do it again. Moral of the story is, different people have different expectations. Now, when it comes to a bicycle, 99.9999% of people are going to expect it to steer a certain way, but the way the handlebars are, the heights of different things, and so on, do you expect it to be more upright, more forward, more what? People's expectations are going to vary. You need to understand your customers in order to do SQA. It's not just go and test it and does it crash. That's like level 0.1. Checking does it crash. Does it actually do what they expect it to do? Do you get into bad situations? That's what you need to do for SQA. Sometimes this gets to a very adversarial setup. Unfortunately, this is more truth than joke. In particular, the dimension between QA and everybody else. QA as seen by developers, QA as seen by designers and PM and so on. Yeah. Understand that you are all on the same team. I brought in user experience design to some of my teams. By far the best thing that I did, because we could not figure out how to actually design a user interface until we had somebody in UX, and our product quality shot up. The day Marcos joined, oh my goodness, it was just suddenly, it's like, he would come up with things, look at it, and go, of course, that's brilliant, it's exactly what it should be. How did we never think of this? And it was so obvious after he'd written it. After he'd just drawn it, I was like, yeah, why don't we do something like this? I was like, that's brilliant. And we just go and implement it because we knew how to do the implementation. We didn't know how to do the design. Similar with QA. It's easy to go through and say, oh, why do you want me to change the look to be this way? Or why do you want me to verify this or check that and so on? You're on the same team. You're trying to get the same job done. Make it a conversation. How do you move forward with the best product? Don't just throw things over the wall at each other. That is a sign of a very dysfunctional organization. When it's like, oh, here's some code. Wah. Oh, you found bugs? Oh, crap, I guess I got to do more work. No, it'd be like, where did this come from? How can we get to this faster? How can we get a better, more reliable product? So, to understand a little bit of the process, because I know some people haven't been through this is a common set of steps that I have seen across many organizations. It's a little bit simplified. Some of you have probably already seen things like this. Realize that this is just an abstraction of many things that I have seen. Your organization will be different, guaranteed. But just generally speaking, the way things are going to happen is you're going to have some requests come in, you do some work, and then you make some kind of a release candidate. And you send that to get feedback. Why? For the same reason we talked about with versioning. And your QA, who again we talked about, needs to be somebody else. It needs to be somebody other than you because you are too tied to this is how I built it. I built it with these expectations in mind. You need to get somebody else to step back from the process and say, hey, if I'm using this cold, does this make sense? And they will have feedback. You may not want to hear this feedback. This feedback will oftentimes be hard to take because you've designed it with a certain mentality in mind that may or may not match the customer. Actually, some of the worst, most heated debates I got into in some of my startups were, what does the customer really want? It was nothing technical. It was not, oh, we can't code this way because that's suboptimal, or we need this to work this way. It's a good example is working on a quadcopter. The battery is at a level such that you must turn back now, or you will not make it back. I called that a critical warning. I got pushback saying critical is going to scare the customers. You can't call it that. To be fair, they're right. I wanted to scare the customer. I want to tell them, this is critical. You have to do something. But the feedback was, this is, it's going to cause people to panic. We need to make this easier for them to understand. And this is where we went back and forth. The point is not whether I'm right or they're right. We both have valid points. And it becomes a question of how do we really get through what is the right thing for the customer. And moreover, the whole idea of this is that this is an iterative process. You're going to get feedback. That turns into requests. You make some changes, and then you get feedback. And this should be happening frequently. You all have talked about agile versus waterfall, right? That's been covered? Yeah? What's the biggest difference, especially looking at this? What's the biggest difference between agile and a waterfall or a planning-based approach? Any thoughts on what are the differences? Yeah? Yeah. Yeah. It's a lot more iterative. What I have seen in practice, it's essentially the frequency. Agile aims to do this at least once a month. Waterfall will be anywhere between 3 and 12 months. And actually, my experience has been that the best waterfall-style project managers and the best agile scrum masters, project managers, facilitators, whatever you want to call them, are actually closer together than the strict adherents. Because a really good PM knows they need feedback. A really good PM is not waiting until the end of the project to say, hey, we developed exactly what you asked for. They're going, I don't trust these requirements. They're going through and saying, let's get some feedback. We're 3 months into the project. Hey, give me a set of code. Cut me a release of the project. I'm going to show it to some people on the DL. Is this heading in the right direction? And they will adapt their project plan. Not what you're supposed to do in waterfall, but it's what successful PMs do. Agile project managers know that they can't just be like, YOLO, we're going to develop whatever we can. They're going to be thinking, hey, based on this velocity and based on where things are going, this is roughly where we're going to be in a year. They try to build in predictability, which is not per the Agile Manifesto, but it's the way things work when you have to work with enterprise. So it's really just the frequency changes. You have the same overall ideas, your frequency changes a little. So yeah, don't put too much stock into this. This was just meant for people who have not seen a release process to understand that you go through this overall idea and the details are going to change wildly based on your organization. Questions about QA and a little bit of this release process before we move forward? All right. Let's talk a little bit about deployment. I don't want to spend a lot of time on this because I think most of you all, we've sort of talked about a bunch of this already. So you've now written your feature, gotten it reviewed, and QA has approved it. Congratulations. Now what do you do? Open-ended question. What do you do at this point? Are you going to, yeah? Upload it to the App Store. Good answer. If you have something that's a little bit more of a web interface to it, what might you do? Sorry? Collect usage data, but before that, how do you get people using it? You've talked about this. The marketing term that I referred to earlier. DevOps. Give it to your DevOps team. Go through the DevOps process. Get it out there. Once upon a time, we actually would give people sneakernet version USB stick stuff. It depends a lot on your organization and your product. Are you going to put this as a ZEP file on a server? Are you going to do it DevOps style? Are you going to put it into an app store? Physical media. People still use physical media for a lot of video games, things that are gigabytes or terabytes big. You know, people ship disks around. It also varies a lot by part of the world. We are enormously privileged here in Singapore that we have just ridiculously fast internet. You know, other parts of the world, that's not the case. What if your product is something where the software is pre-installed on a device? Like, you know, the quadcopters I used to work on and so on. God, getting those updated in the field was such a pain. You have different deployment strategies. You need to think about this. Why do you care about this? Why is this not just somebody else's problem? Well, first off, if it's your startup, you care about this problem. If it impacts how you do your work, you care about this problem. If things in how the installer works or how the updater works or DevOps team screwing things up means that you get bug reports and so on, you care about this problem. So you have to think about deployment to a certain extent and that it affects your work. At least be cognizant of what is your deployment model. How do you get updates? Sometimes it'll be an easy answer. Sometimes it'll just be like, yeah, we go through the App Store. Okay. What's the App Store release process like? Anybody ever tried to get an app into the Apple App Store in December? Anybody know why I might be asking that question? What happens in December in the US that's kind of a big deal? Black Friday is November, but you're not too far away. Christmas. Apple reviews shut down in December for, or at least they used to, I don't know if they still do, for 1 to 3 weeks. So you have a window where you submit an update to the App Store, it will not be approved for 1 to 3 weeks. They will not even look at it for 1 to 3 weeks. So know what your deployment process is. Understand what constraints that does to you as a developer. Know what that means. It'll affect your dependency management, it'll affect your reviews, it'll affect your testing, your QA, and so on. If you're DevOps and you're doing rolling releases, you have a very different strategy and it affects how you develop features. If you have an app store and you have to make absolutely certain that anything that you want in customers' hands before Christmas is there before the first week of December, you have to be thinking about that. So yeah, you think about speed, scalability, risks, costs. This is fairly straightforward, but friction is important. You don't necessarily want zero friction. You want to make sure that there's just enough friction that you're checking quality, that things get through smoothly but not too smoothly. And that's everything I have for QA. Very sensitive mic. Questions about deployment and QA at this point? Yeah?
Sorry, what's friction?
Friction. So friction is basically like, I'm modeling it from physics, but like, let's say you have your SCM tool, GitHub, whatever. A zero friction system would be just like, or minimal friction would be just you click one button, it's in production instantly. That's low friction. Going through the App Store or physical media and so on, that's high friction. It's how much effort and how much time does it take from when you decide to deploy to it actually being used by a customer. That's friction. And you don't want it to be zero because things will actually change too fast. It's like trying to walk on ice. If it's too easy, it's very easy to get the wrong changes. You want just enough friction that you catch anything that shouldn't get to customers before it gets to them. So you want a certain amount of QA, you want a certain amount of steps in between. Now you don't want friction for friction's sake, but you do want to make sure that things get checked. You have a chance to catch things. And actually the best designed systems have moderate friction for normal changes, but then if you have a critical bug fix or you have some critical change, you can bypass it to a low friction method that gets things right away. That's by far the best. Not always possible, unfortunately. All right, we're actually getting close to time. This is good. So to wrap up, we talked about a lot of different parts of software development practices. We talked about source control, and not just like Git, but how do you properly control your source code, avoid the problems that, for example, ByteDance had. I mean, every company has had problems like these. Talked about coding styles and the importance of being on the same page. Talked about versioning and releases and making sure that people are on the same page in terms of what does a release mean. Talked about dependencies and deprecation and how this is probably the most painful but most important part of software engineering and software practices. Code review as being the single most important place that you will learn things through your career as a software engineer. And then QA and deployment in terms of how you actually get code to customers in a high quality way and what you need to think about that way. And the net summary of all of this is you have to think about your organization, your project, and how do you optimize these practices for what you need to get done. There is so much more I could talk about. The Google Software Practices book has like, I don't know, a quarter of it on testing, with good reason. Good testing is what makes the difference between a mediocre and a great product. But that's, I am sure you will go through, if not lectures, courses on testing, so I didn't cover it here. Refactoring and large-scale changes, especially at an enterprise level, is a whole set of practices by itself. And it relies on testing and other things. I understand you'll be going through a lot of these tools like build systems, continuous integration, static analyzers, and so on in a separate lecture. So do pay attention to those, come into how you apply a lot of these. And documentation, I didn't talk about it because I didn't feel I would be able to add a whole lot beyond what you will probably cover elsewhere, but documentation is a deliverable. Treat it as such, treat it as part of your code. What documentation is needed, how you do documentation varies from organization to organization. So pay attention to that. And also pay attention when you are consuming a library. What documentation is useful to you? How do you wish it was done? So that when you go to produce your own, you know what to do. That's the best way to realize this. Don't write a bunch of documentation nobody will ever read. But write the documentation you wish you had, and that will serve you well. My key takeaways for you, learn the best practices. There's the Google Suite book is packed full of them. If you get a chance to read it, go through it cover to cover. It's fantastic. Learn what these practices are so that you can then realize that there's no silver bullet, so you ask questions. Figure out how to work with your teams. You know what the best practices are, and now you figure out what is the best thing to do with this team. And remember, teamwork, collaboration, consistency will always outperform quote-unquote rock stars. Americans like to make a really big deal about being rock stars and oh my gosh, we need like 100x people and so on. Not true. It's for the movies. Real software engineering is done in teams with good collaboration, consistency, and hard work. Yes, you have to work hard. You have to know your systems. You have to know how to code well. But it's done through teamwork. It's done through collaboration. Google has demonstrated this time and time again, and I'm sure it has been seen at other organizations. I just don't have experience at Facebook or Facebook, Meta, Apple, but I understand it's basically the same. It's done by good teams. Think carefully about what your org needs to get it done, So those are the most important takeaways. If we have time, I want to talk about the difference between more junior and more senior developers. Because this is something that I don't think you will hear anywhere else. These are some things that I have observed from my career. They are not backed up by empirical studies. This is simply, so take this with a grain of salt. These are my opinions. But they've been backed up by about 20 years of experience. The first is that junior engineers are very nervous about their code. I don't want to show you this because it's not really ready. I don't know if it's really right. And that's a bit of ego, and it's a little bit of insecurity. It's also not having your code at a point that other people can look at. Senior engineers, from what I've seen, will show you their code at any point in time. Yeah, I'm sort of working on this. It's not really working. Hey, you got a second? We can sort of walk through this. Like, oh yeah, this part's kind of mungy, but this part's trying to interact with this, and when it does this, I think this is why it's failing, but I'm not really sure. You know about this API. How's this go? And this is code they wrote that morning. And they're going through, this is what it does, what it doesn't do, and so on. And they're able to talk about code quickly. They're able to show you their code. It's not committed. They're not doing a code review, but if you want to see their code, they're happy to share it. They also get to a code review faster. That gets to the long-lived branches versus short-lived branches. More senior engineers make small, focused commits with clear reasoning. More junior developers are not yet able to figure out how to make things focused. One of the most important pieces, estimates. Learning to estimate takes time. It will take you a good 3 to 5 years of practice software engineering before somebody can come to you and say, hey, we think we need something that does this. And unless you've done it before, you'll be wildly off. And that's fine. Realize that. But as you go through, try to develop the skill. Predict how long it's going to take you to do something. And then see how close you get. At first you'll be wildly off, but the more practice you get at sort of going, I need to develop, a new front end for SQL Answer that has a widget that lets you choose a different database style or something. And I think that'll take me a week. You get into it, it's 3. Figure out where did you go wrong? What was it? Oh, the database plugin I misestimated. Or maybe it's like, oh yeah, UI takes longer than I expected. And try to adjust that going forward. Very strong professional skill. And lastly, take CR feedback well. Somebody suggests something to you, run with it, see where it goes, mind your own inertia, and learn from it. It's probably one of the hallmarks of a more experienced developer. This is a great quote from Asim Hussain. Basically, the net of this is keep moving forward. Your processes, your architecture, and so on will always be in evolution. Keep that in mind, keep moving forward, and good teams push each other to always be improving. A few resources, these will be in the slides. This book is fantastic. Even just preparing for this lecture, reading something, it's like, oh yeah, wow, these people are good. Titus, Tom, Hiram, a whole bunch, is like 6 or 7 other people who contributed to this. It's a great book. There are others. I understand you've been quoting from the Mythical Man Month, as well as what other books have you been quoting through the process?
We had a couple of them when you were the lecture, but I'm sure you also use partly the
Okay. Yeah. So yeah, there's a lot of good engineering books. The Pragmatic Programmer is another one I learned a lot from. I don't know if it holds up today, but it definitely held up before when I was learning. And that's all that I have for you. So I think we're ending just about on time. Feel free to ask me anything, whether it's about Google and other companies or engineering practices. thank you for being such an interactive audience. Yeah. Yeah. Any questions? Questions about software engineering, questions about what it's like at different companies, you know, questions about projects or anything else? Yeah?
More fun at Google or
Sorry, say again?
is it more fun at Google or
Oh gosh, that is impossible to answer. Both had their moments of being enormously fun and difficult moments. So I really can't put one in the other. The UAV company was Arion Labs. They are now part of, I think, FLIR Robotics, FLIR, the infrared camera company. ClearPath was also a lot of fun. They're another startup out of Waterloo. What I will say, that is something that is a very clear takeaway, the team matters a lot more than the company. Because I had a really good team at Google. I talked to many other people who worked at different teams at Google, and they had a horrible experience. I talked to other people who had even better experiences than I did at Google. And yeah, I've heard the same thing at Amazon, Apple, Facebook, whatever. Your team matters a lot more. It's actually why I never ended up joining BlackBerry, aka Research in Motion, even though they were started and headquartered in Waterloo. I just never connected with a team that I really wanted to work for better or for worse. I missed out on probably several $1 million in, like, you know, equity out of that, but whatever, such is life. Other questions? All right, well, I'll be around. Yeah.
I still have a question.
Yeah.
I'm curious, I guess you already mentioned that, like in practice, there's not always a big difference between plan-driven and agile approaches, like depending on how you implement it.
Mm-hmm.
So I'm just curious, like depending on your experience, like did you perceive more traditional, let's say, plan-driven approaches, and like if so, how would you compare your experience with that?
Okay, so so the question was between planned versus agile practices. And to clarify, I'm not saying the two are similar. I'm saying the best project managers would borrow from the other side. So the best plan-based project managers would lean towards the agile and adapt the plan. And the best agile project managers would lean towards planned and try to build in predictability. But the two are definitely not similar. The two are quite different. And which one and when and where matters a lot on the organization. So I have seen some organizations that did plan very, very, very well. And usually it's because they had very rigid requirements. Aerospace is a good example. Things had to be extremely rigid. And it was very difficult to work with, but they made it work. Startups would typically be more agile. Ironically, I've had a few startups that did not want to be agile because they had other parts of the organization that were hardware-oriented and wanted predictability. I had to tell them that, no, the software for a startup, we needed to be more agile. What I have found is that the best organizations are the ones that adapted to change. And adapted to change that was relevant for their organization. And found a way to cut out changes and cut out the noise. Because there will always be a push to, oh, adapt to this, adapt to this, adapt to this. This is changing, this is changing, this is changing. And the really good organizations would figure out, this is what we have to focus on. This is noise. Because if you try to change too often and too quickly, you get nothing done. But if you focus and say, this is where we need to go, oh, we need to make a change, we need to steer a little more this way, you get to where you're going. And that was what I found worked by far the best, especially at the PM and the organizational level, is figuring out what changes have to be adapted to and which changes do you ignore. Yeah. Cool. All right, other questions? Yeah.
how, like, remote versus in person is your work being these in which you
I have done both. Both are very doable. It depends a lot on the organization. I find typically my personal preference is to have a smaller, tight-knit team that really knows each other well and be in person as much as possible. Does not have to be 100%, but the more in person, the better, the more contact you have that way. Remote can work, but you have to make it work. It actually takes a lot more effort to synchronize, and everybody has to put in more effort to synchronize. That said, there are organizations that make it work. And especially what you cannot compensate for ever is commitment. You can have people that show up in person that are not committed. They're just like showing up to punch a clock, collect a paycheck. They'll get nothing done. You have somebody who's remote but is absolutely engaged in the project. They want to make absolutely certain it works, and they are calling, emailing, messaging, day and night. They're like, this project's getting done, and they'll accomplish 100x the people who are just sort of showing up easily. That said, is again a lot easier in person. But if you have commitment, you have people who are, hey, we're going to get this done, we're going to make this project a success, that's your number one determinant. Yeah. So, not quite answering your question because it is somewhere in between, but yeah, that's what I've seen. Yeah. Any other questions? Cool. I think we are at time, so thank you very much. Thank you for being a wonderful audience, and best of luck with your projects. And yeah.
Thanks a lot again for the excellent teaching.
I'm glad. Thanks. Thank you for this. This was, there we go. This was a lot of fun.
Should we come